On today's episode, was the SpaceX explosion a failure? Yes. Unexpected? Not really. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. So SpaceX has launched the biggest rocket ever built by man, bigger than even the legendary Saturn V from the days of Apollo. SpaceX's gigantic booster got the stack 24 miles up to the point of staging before the vehicle failed catastrophically. Now, while the mass media was working overtime to label the loss of the launch vehicle as a success, the simple fact is it wasn't. It was a failure, and a spectacular failure, but not an unexpected one. Testing complex engineering systems, especially those where multiple systems interact with each other, is expensive and time-consuming. In rocketry, the original Saturn program from the early 60s, managed by a corps of engineers that cut their teeth on the German rocket programs of World War II, well, it was tested in the traditional stepwise fashion. The first Saturn I was launched with a dummy second stage and no third stage. Each successive test flight added more complexity, qualifying the first stage, then the second, and finally the entire launch vehicle. Now, the result was a spectacularly successful program, with the Saturn I series eventually launching 5 crewed Apollo capsules successfully. Now, what makes this incremental testing methodology work is unlimited time and money. The alternate strategy, the one used with the gigantic Saturn V moon rocket, was all-up testing. The idea was to assemble the entire vehicle, all 3 stages plus spacecraft, and launch the entire vehicle right from the beginning. Now, the risks for Saturn V were enormous. Everything about that system was new, with cutting-edge technology and none of the computer-aided engineering available to design teams today. The first all-up test was Apollo 4 in November 1967, and incredibly, it worked. A follow-up test, Apollo 6, had multiple problems, but nothing that prevented the first crewed flight of a Saturn V, Apollo 8, in 1968. Now, the need for speed in racing the Russians to the moon forced all-up testing, and frankly, NASA got lucky. SpaceX launched an even bigger vehicle, and they weren't so lucky. Now, the price of all-up testing is a high risk of system failure in exchange for more data on the entire launch faster than would be possible with conventional incremental test methods. If you want to make an omelet, you have to break some eggs, and SpaceX is obviously prepared to break many to get the large and complex Starship program flying reliably. So was the first flight successful? Well, clearly not. But we can't determine overall program success until we see how many flights are needed by the SpaceX team to qualify the vehicle for crewed flight. NASA set the bar: 2 uncrewed tests. To match that standard, SpaceX will have to launch the next one successfully. But will they? With modern engineering design, simulation, and testing tools at their disposal, plus half a century of large spacecraft design heritage to draw from, I expect the answer will be yes. Well, that's it for today's episode of End of the Line, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.